conference will now be recorded.
Yeah. Okay. Uh, Hi, Ravi sir. I think we can start our session, right? Yeah. Okay. So let's start our session. So, yeah. And if anyone joins, anyway, this is a recorded session our team would share. Okay. So, hi all. Good morning. So, welcome to the Snowflake demo by Provoke Trainings. Okay. So myself, Shaker. So I have over 12 years of experience of that, nearly around 5 years of experience on Snowflake as a data engineer. Currently working for a MNC. Okay, in the senior data engineering capacity. Okay, so I am a mm, certified data engineer from Databricks, Snowflake, and Azure platforms. Okay, so in this demo session, okay, I want this to be more interactive. So we have a lot of time to go into the technical things and everything. So I wanted to understand what you are expecting from me, and what what are the things that we are planned to take you through, and also introduction towards some what is Snowflake and what kind of capabilities it is having, along with some what, like I said, right? So what we are going to cover as a part of this training. Okay, so that's the plan. I think we are good to start the session. Before we start, if you have any audio issues or any concerns, please let me know. So before we start, yeah, we'll address them. I hope everything is good. I think, yeah. So yeah. So please be more interactive. So if you have some question, so in between I'm going to be stopping and asking you. So please try to be more interactive. Okay. So coming to a demo. Okay. So as you know, nowadays data is the new new oil, right? So in earlier earlier days, so oil is the most growing business and like that. So now organizations depends on the data. Okay, so how, and because of that, so the data they can be used for a lot of reasons. So for analytics, for predictive analytics, for engaging with respect to the artificial intelligence. So there is a lot of advancement in this, right? So organizations collects a tons of data from different types of systems. Okay, so collecting the data doesn't make any sense. Okay, unless you retrieve some value from it, right? Where unless you make some sense of it. Okay, so the organizations collects the data from different types of systems, okay uh, transactional systems. So these typically called as OLTPs. So you may know, okay, you may know people that has some experience in the data domain, you may know of this. Okay, so this OLTPs typically involve okay, the systems order management, sales management, or payment processing systems that does the business operations on real time. Okay, does the business operations on the real time. So that is one type of source, and some specific operating systems ERPs, operation systems, so this is operation systems means business operation systems, not our OS. Okay, so these would be like ERPs, enterprise resource planning systems, or CRMs, customer relationship management systems, or any kind of other core business processes inventory management, HR, finance, like customer interactions, all those. Okay, so that would be the second type of source. The third type of source is the different ways that organization collects the data is some external sources. Not everything the data that that particular business cannot able to collect, right? So there would be some partner systems, there would be some market, open source databases, there would be some different types of APIs. Okay, for example, take Swiggy only. Okay, so they that uses a mapping, right, mapping service. So in order to show us the real time location of our order, or that okay, person that is delivering the order, right? So it uses a mapping service like Google Maps, such kind of a service. So that data is shared to us via an API. Okay, so like that, okay, so some external third party um, systems, Okay, so they are going to be sharing that data via some files, flat files like that, or some databases. Okay, or APIs. Okay, like this, or if you have like a social media, or there are, these are the different type of systems. Like these collects the data for much more in a much more broader sense. Okay, and finally each organization would have their internal source systems also. Okay, so that would collect the data for supply chain management, or HR management systems, or marketing automation systems like that. Okay, so these are the different types of sources that you would have. Okay, so the this all of this data is going to be collected and maintained. Okay, so that the business can able to derive some value. Okay, derive some value. So otherwise there is no need for storing the data, there is no need for it, right? So unless they can able to get something out of it, so derive some value, so that they can able to enhance or improve the business operations. Okay, enhance or improve the business operations. So for that, there a new domain of data analytics has been started. Okay, so okay, so you may have know about OLTP, okay, and OLAP, right? So can someone answer what is an OLTP and what is OLAP, and what is the main difference between this? Can someone? Like I said, I want this to be more interactive. Okay, uh, if you know, it would be good. Okay, so OLTP systems are transactional systems, like I said. Okay, so these focus on day-to-day business transactions that are happening at real time. So, like I said, customer orders, payments, or inventory updates, like all of this. Okay, so these OLTP systems, that's where the business is running. So, in the back end, it's going to be a database, a relational database like that. Not only relational nowadays, there are non-relational databases called as NoSQL DBs. Okay, so these are the transactional systems. Okay, where our day-to-day businesses are okay are doing the operations on real time. Okay, so these systems are OLTP systems are optimized for speed and reliability. Reliability means it's their withstanding. Okay, it's their capability of withstanding like concurrent operations, thousands and millions of concurrent operations. Okay, so it is optimized for that kind of speed and reliability kind of operations. So where OLTP usually are okay. So here you do the single row kind of transactions. Okay, single row kind of transactions. Okay, so that means when you place an order, okay, when you place an order, so it's going to be like adding a new record to that orders table, right? Okay, so in backend we need to understand everything. When you are entering into the data domain, or if you are working into in the data domain, everything you need to think in terms of databases. Okay, how in the databases that particular transaction is going to be committed, is going to be maintained, like that. Okay, so here when we place an order, or when we change something to that order, okay, so that are going to be happening at a row level transactions. So this OLTP systems are optimized for single row operations, like quick inserts, updates, and when you cancel order, you should be deleting that order from the transaction system, right? So like this, these are optimized for um, Okay, these are optimized for single row operations. But by analyzing the current orders are like that, businesses cannot able to understand what is their demand, what is the inventory that they are having. Like that kind of analysis they cannot able to do on these systems, right? So that's why they need a different kind of system called OLAP. So this is analytical processing systems. Okay, online analytical processing systems, so which are designed specifically designed to analyze, okay, analyze a huge amount of large volumes of the data. Okay, large volumes of historical data, this is very important in order to understand the trend. Okay, seasonal demand. Okay, understand the trends based upon the users, what is their shopping, okay, what is their order history, what kind of products that they are interesting, like that, right? So basically OLAP is a system that would analyze a large volume of historical data. So this historical data, how long they would maintain, that's completely up to their requirement. So some organization would maintain past 5 years, some organizations would maintain up to 10 years. But the organizations that have huge amount of data that is flowing, right, so they would go for a shorter period also. Okay, so this OLAP systems can able to support the complex queries, can able to uh, support the reporting requirements. Okay, so usually through reports business people can able to understand the data, right? So there would be like a sales reports, order reports, like that can give us some insights into, okay, what kind of data that we are managing. Okay, and it also gives us the aggregations at day level, week wise, or monthly level, or even some trend analysis, like how what is the like a season to season trend, or year to year trends, how they are helping in order to make some strategic decisions, so that they can able to bring more revenue, they can able to improve the how they that particular business is happening. Okay, so everything that is related to analyzing the data is going to be happening on OLAP systems. Okay, these OLAP systems, right, these OLAP systems usually the data warehouses. Okay, this is the traditional in traditional architecture only data warehouses used to be there, but nowadays you would see the data lake, okay, and data lake house. Okay, the data lake house, these are the like platforms that would serve as a OLAPs. Okay, um, that would serve as a OLAP. Okay, so OLTP is more focused on day-to-day operations of that particular business, whereas OLAP is more focused on the analyzing the data, historical data, so that they can able to derive some value from it. Okay, is that clear? Is that clear? Even in chat, that would be helpful for me if you are
Yes,
following.
yes, it's clear.
Yeah, thank you, Naveen. Yeah, thank you. So, so you would get a question that why not do analytics on OLTP? Okay, can someone answer this? Why not do analytics on OLTP? So, like I said, the same amount of the data is coming from here, right? The OLTP systems itself. So, um, since the data is coming from here, why not do the analytics on OLTP systems itself? Okay, so there are multiple reasons for this. Okay, because like I said, in OLTP systems we only maintain recent data. So here uh, recent data only, so that based upon the particular uh, okay, the kind of entity, so whether orders like inventory or like that, so we usually maintain recent data only. OLTP holds only recent data, that is usually for few minutes, few months. Okay, like a few quarters, like that. Okay, so mostly a year amount of data is going to be maintained, because as this time duration goes on increasing, the amount of data is going to be increasing, right? So as amount of data is too large, then these OLTP systems tend to not perform well. There would be a performance impact. Okay, there would be a performance impact on that. Okay, so basically this okay, so performance impact due to due to the high volume, that is the one point that we talked about, because as the data is going to be increased, the okay, so you need to scale the uh, OLTP systems, and the scaling would become very costlier, because these are optimized for single row operations. When you are analyzing a historical data or huge amount of data, these systems tends to perform not well, okay, when compared to the OLAP systems, because these are not designed to execute or process complex queries, right? So that's the reason. And second reason being, so there would be a resource contention that would block the okay, that would block the incoming data. Okay, so that would block when you are trying to uh, read the data from a specific table. These OLTP systems would place a kind of lock. Okay, and okay, so when you are doing some changes to that particular table, right? So it would place a lock. So that means you cannot able to do any other kind of operation on those. Okay, so that is the another one. And as as when you run analytical queries on the OLTP systems, so usually that would slow down the our core business operations that we are we design this OLTP systems to do. Okay, so that's why we don't want to do the analytics on OLTP systems. Okay, these are going to be the user focus data systems, where if it is a finance, this OLTP systems is going to be have access for clerks, cashiers, or if it is like order system, so warehouse management softwares are going to be doing the transactions into these databases. These are not designed for uh, performing any kind of analytics. So that's why we need to have a different systems called OLAP systems. So in that we have a data warehouses, data lake, and data lake house. Okay, so we'll talk about Snowflake, where it would fall into these. Okay, we'll discuss that. Okay, and it's very important to understand that. Okay, it's very important to understand that. So OLAP systems, okay, or data warehouse, from now onwards I am going to be referring the data warehouse. Okay, so this data warehouses are going to be depending, so from this transactional systems, right? From this transactional systems we are getting the data to the data warehouses. So that means there is a direct dependency here, right? So there is a direct data dependency here. So whatever the data that your business has been collected, so you need to get the data to the data warehouse, so that here you can able to perform the analytics. Okay, here you can able to perform the analytics. So let's call it as reports. So based upon these reports, the business analysts or the business side people, okay, so they are going to be deriving some they are going to be using these reports to derive some value from it, and also at the same time they can able to use that information in order to improve this. Okay, improve the business operations. Okay, improve the business operations. You got this, right? So it's kind of a feedback loop. Okay, so we derive the insights from the OLAP systems and feedback that information, or feedback that observations, so in order to improve the business operations, how you are performing in the OLAP. Okay, so this is kind of a circular operation. So that's why you see there is a lot of enhancements that over a period of time you may have done, because you are deriving some value from the existing data, and you feel that there is a need for some more information, so that you are going to be improving your you are going to be collecting some more information from the uh, source systems, and that data is going to be again getting into our data warehouses. We are going to perform some analysis on that data, and that analysis is going to be again improving the business operation. So this is kind of a okay, continuous operation where the business is trying to improve. So that's why the data analytics plays a major role in current trend. Okay, um, in order to improve the business, and not only get the insights on how the business is conducting, and they can also able to prepare for the upcoming demands and like that. And also the final thing is final important thing is they can able to improve the business operations by uh, observing how okay, a particular KPI is performing, so that they can able to do enhancements in order to uh, in order to improve their day-to-day operations. So that's why we need to like segregate the OLTP systems and OLAP systems, and we need to extract the data from transactional systems to the data warehouse. So this is where a popular term would come into the picture, that is ETL. Okay, so ETL is nothing but E stands for extract, T stands for transformations, okay, transform, L stands for loading. Now this has been evolved into a ELT. Okay, so with the emergence of cloud based systems, right? So ETL no longer is a valid option, because the scalability that this cloud platforms are offering. So it makes sense to go with the ELT. So but the steps are going to be the same. So you need to extract the data from the source systems, like the source systems that I have listed, right? Four categories. Okay, so from all those systems you need to collect the data from there. Okay, and earlier we used to transform it externally, okay, like standardizing the data, normalizing the data, and finally okay, like deriving some new values from the existing data, and finally loading the data into our data warehouse, loading the data into data warehouses, because earlier the data warehouses are schema on write. Okay, that means we need to model the data externally before we can able to okay load it into that specific table. Okay, so these earlier the data warehouses used to be a schema on write system. So okay, so you would understand what is schema on read, what is schema on write, everything later during our course. But just okay, so that's why these transformations are needed in order to model our data into our target requirement. And finally, once you do the transformations, you are going to be loading the data into our data warehouse. Okay, we are going to be loading the data into our data warehouse. Okay, so I hope it is clear, right? Any questions?
Yeah.
Yeah. So, yeah. So, data warehouse is just another database which is optimized for analyzing complex, large volumes of data and complex queries. Okay. So, it's a another SQL based database. Okay. So that is designed to store the massive amounts of data. Okay, especially historical data. I talked about it, right? And this data is going to be storing the aggregations based upon our grain that we want. Okay, so you wanted to you want some tables to be at weekly aggregates, you want some tables to have some daily aggregates, like that. Okay, so that contains historical and aggregates data, so which has been derived from the transactional systems. Okay, from the transactional data from multiple sources, and that is being used to query and analyze the data. Okay, that is used to query and analyze the data rather than the for business operations, for the transactional processing. So whatever I have explained, I have keep it here in a single sentence. Okay, I hope it is clear. Okay, so basically, data warehouse is a system that primarily supports the OLAP workloads that serves as a centralized repository for okay, historical and aggregated data for complex analytical workloads. Okay, for complex analytical workloads that would support the um, decision support systems for that particular business. Okay, so on top of this data warehouse, right? Usually we'll do the analytics. Okay, usually we'll do the analytics like this analytics maybe nowadays it has been evolved. Earlier it used to be like tabular reports, but now some visual BI tools have came into the picture, like a Tableau, Power BI, like that. And there is also okay, machine learning or AI related data analytics. This is comes under the advanced analytics. So there are like machine learning models that can able to analyze the historical data to give the predictions. Okay, like that. Okay, so like this, these are the different types of analytics that you can able to do. Okay, on top of the historical data that we are maintained. Okay, so for this data warehouse, for this, and there is a lot of evolution that has happened on this data warehouse systems. It's not the same systems that are that is available in 90s. The same data warehouses, the characteristics and the capabilities has much more evolved in last 3 decades. Okay, so but it is very important for us to understand the characteristics of data warehouse. Okay, like these are the four major four pillars of a data warehouse. So it's a subject oriented means, so here each data warehouse system would have, okay, is the data in these systems are going to be organized around a key business subjects like sales, customers, products, or rather so here it is going to be focusing on analyzing that particular business units. Okay, analyzing the particular business units data. Okay, so it's going to be uh, okay, subject oriented. Okay, so usually you would have databases created for sales, separate database earlier, marketing database, like that. Okay, so and then integrated is nothing but it combines the data from multiple heterogeneous sources into a consistent and unified format. Okay, so that all the data is in standardized format in our data warehouse. Okay, so that has been collected from different types of sources. Okay, and it's a time variant data. That means it stores the historical data along with the time dimensions, so that you can able to do the uh, trend analysis, like how the data is changing over a particular trend or over a specific periods of time, in order to analyze with respect to the time. So we store this historical data. And finally, the persistent and non-volatility of data warehouse is nothing but once the data is loaded into the system, we would maintain it for its life cycle. Okay, so that means whatever the like a time period that we would maintain until that, like for example 5 years of the data is has to be maintained for that particular organization for analytical purposes. So that data is going to be present in that system for that duration. So our data is going to be persistent. Okay, and does not change for 5 years. So does not change here means, so if from the business side, so for one customer places an order for 100 units, later he cancelled 50 of units, that changes here is going to be tracked. Okay, um, okay, both these changes, like initial order is 100 units, the second later he changed that quantity to the 50 units, right? So in data warehouse we would maintain all of these changes. So there would be a two records that indicates this information, whereas in transactional it would only shows the current status only. Here 50 units of order that the particular customer has been placed, whereas in analytical systems, so the entire history is going to be maintained. Okay, so that's why once the data comes here, it would not be it would not lost, so the data is not going to be changing. Okay, so we would have some active flags like that, so in order to get the current status of that particular order, but we would maintain the entire history also. Okay, so that's the four characteristics of a data warehouse. Okay, so in data warehouse, it solves for a specific particular subject. Okay, whether it is marketing, sales, supply chain, or whatever it is. Okay, and we collect that whatever the data that we collected here is going to be integrated across. If there are multiple sources, all of the data is going to be standardized, so that standardized and unified format would transform it into a unified format, and the data is going to be stored for the historical purposes, and the data is not going to be changing. Okay, okay, and so here this is a ETL. As you can see, we would have a external system where it's kind of a operational data store or staging area. There would be a lot of names. That's where we'll do the transformations by using some data integration tools like Informatica, Talent, like that kind of platforms. And after transforming, finally we will load that. So like I explained. Okay, but newest trend is okay, so having this ELT. Okay, so the raw data that we have collected over the source systems, right? So we would extract it. So whether it is a full load or incremental load, based upon how the data pipeline that we have designed. So we would extract the data from these systems and directly load it into our data warehouse. Okay, this data warehouse is the modern data warehouses. Okay, modern data warehouses. So I will talk about the data warehouse evolution in the next slide. Also, these are the modern data warehouses. So within our data warehouse only, we'll do the transformations, and this is the current trend. Okay, the ELT process. Okay, the ELT process. Yeah. Any questions? Yeah. So over a period of time, like I said, 1990s, that's when the inception of data warehouses has came into picture. Okay, so at that time it used to be traditional RDBMS based systems only. So these are on-premise that only supports the batch ETL. Okay, that only supports the batch ETL. So these are the 1990s. We have this kind of systems, and there are some customers that are still here. Okay, that are trying to migrate here. Okay, so we'll see that. Okay, how to get the data and what are the steps in migration. Okay, so that usually involved, we'll talk about all of them during our okay later sessions. Okay, so initially for overlap systems, because we need a dedicated system or dedicated database that is optimized for that is optimized for analyzing, right? So here we have in 1990s we used to use this RDBMS, and then in early 2000s, okay, there is a appliance based data warehousing systems came into picture. So these are the MPP systems, massively parallel processing systems. Okay, so these systems are hardware optimized, so the entire appliance is going to be given by these organizations to that customer. Okay, so these are optimized. Okay, these are optimized to handle a huge amounts of data. So these are hardware optimized MPP systems, massively parallel processing systems. Okay, so in the Teradata, Netezza, Oracle Exadata, like these came into the picture. Netezza is from IBM. Okay, Exadata is from Oracle, Teradata is from Teradata only, and Vertica. Okay, so these are, and there is other systems like Greenplum, and all of these are appliance based data warehousing systems. Okay, and then okay, so there is a slight period where Hadoop is on prem. Okay, and then there comes Okay, uh, like a um, like a Cloudera, Hortonworks, this kind of service providers have came in order to give the offering the Hadoop ecosystem on the cloud. Okay, so then we evolved. So what is the issue here, right? So far here it is only supported the structured data. Okay, structured data, and here the single source of truth, because like I said, data warehouse is a subject oriented, right? So till this point, okay, so there used to be like some kind of a data silo, like each business unit's data is present in separate server. Okay, separate server. So in order to uh, perform any cross business units analysis, it's not possible at the time. Okay, so then they wanted to have a single source of truth that can able to handle, okay, that can able to handle even semi-structured and unstructured data. So with that, Hadoop came into the picture, like late to 20, okay, 2000s, okay, late 2000s and early 2010s, Hadoop came into the picture. Okay, on Hadoop, then the Spark, so Hadoop, the processing engine is map reduced, so which has lot of drawbacks when compared to later, like it's a new generation one, which is Spark. Okay, so uh, okay, so the data is going to be maintained in the HDFS, and Spark is the processing engine. Okay, earlier it used to be MapReduce, but later there are some performance bottlenecks. In order to solve them, Spark has came into the picture, and then they wanted to combine these. So here the data management becomes very difficult. So some companies or organizations wants both of these capabilities. Okay, so at the time, cloud based initial database systems, data warehouse systems came into picture. Okay, like Redshift, BigQuery, and Azure SQL data warehouse. So that at that time, that's the name. Now it has evolved into Synapse. Okay, okay, so here, whatever the architecture and everything that is there, right? So they kind of bring it onto the cloud. So these are the initial DB offerings. Now, okay, so Redshift is from AWS, Azure SQL Data Warehouse is from Microsoft Azure, and BigQuery is from GCP, like Google Cloud Platform. Okay, so these are the initial data warehouse, cloud data warehouse offerings. Okay, so where the main here they have achieved is, so they separated the um, okay, they try to separate the storage with compute. In initial versions it's not possible, but current Redshift, current Synapse, current BigQuery, right? So they do the storage plus compute separation. So those are inspired by the Snowflake. Okay, so Snowflake is the first tool that introduced the, okay, storage and compute separation. Okay, so and then there is a specifically designed for cloud. So the entire architecture has been reimagined and built from the scratch in order to support the cloud platforms. Okay, so in that, Snowflake came into the picture, okay, in 2014. Okay, they released to the public in 2014. Snowflake is founded in 2012, and usually we came to know about Snowflake much later, like in 20, like 19 to 20s, the organizations like started to understand the full capability of Snowflake. From that time onwards, now Snowflake is the number one, with respect to number of customers, with respect to the market share in the okay, analytical data landscape. So Snowflake is stands at number one now. Okay, and there is also Databricks, that is a big competitor for Snowflake. Okay, so these Snowflake and Databricks share the approximately 90% of the market share. Okay, approximately 90% of the market share. So you can uh, Okay, so you can just imagine that the number of opportunities that you would get, okay, uh, by upskilling in these areas like Snowflake and Databricks. Okay, so these are specifically cloud designed, cloud native, multi-cloud systems like a Snowflake, Databricks, right? So this has a lot of demand. Yeah. So that's how over past 30 years our data warehousing systems has been evolved. And Snowflake is a data lake house system. What is data lake? What is data lake house? We'll talk about uh, if possible in today or in tomorrow's session. In coming sessions, we'll talk about them. Yeah. Okay. Any questions? Because here over this, what organizations were looking, right? So they wanted to, these are the okay, ideal data warehouse features that any organization is trying to look for. Okay, so our system should able to exhibit strong performance. Okay, and on demand scalability, so you don't need to manually scale the resources from a quarter to quarter or like that. Okay, so when there is a requirement for additional resources, whether it is storage or compute, on demand our system can able to support that on demand scalability. Okay, so and it should able to support, okay, all formats like a structured, semi structured, unstructured. So what is the difference between structured data, semi structured, and unstructured? So what are the, okay, examples of it? So structured means usually rows and columns, whatever the data that you can able to visualize in rows and columns, right? That is the structured data. Okay, so that's how the data is maintained in RDBMS systems, relational database systems. But there are some formats like a JSON, XML, right? Okay, or Parquet like this. These are called as semi-structured data. Okay, because there is some structure to it, but it's not traditional table like structure. Okay, those are called as semi-structured formats, and there is unstructured formats also. These are usually like a PDF, image, okay, any kind of binary files, we classify them as unstructured data. Okay, so our like any analytical system can able to support all the data formats. Okay, so you don't want to maintain a different system for a specific type of data, right? So again that would create a data silo. Okay, so you cannot have a single source of truth. You don't have entire data, your organization data in a one platform. Okay, that is the major issue that we are trying to get away from. Okay, so you should it should support, okay, all the data formats, and very importantly you can able to access the data via SQL. As you know, there are a lot of ways that you can able to access the data like semi-structured and unstructured data by using Java, Python, these languages, but not every data like a data related developer would have those skills, right? Because those are high level languages that has a you need to learn those especially. But for a data professional, SQL is the bread and butter for them. Okay, that means SQL, they are they know about SQL, how SQL works, and how to use SQL in order to interact with the data. Okay, if you have a system that can allow you to query the uh, okay, not only structured data but also semi-structured data, if possible unstructured data, then that is the kind of system that organizations want. Okay, and you want to have a, at the end, all the organizations would look for the cost only, right? Which is the more cost effective. Okay, so our data warehouse should be cost effective. There should not be spending millions of dollars on the licenses only. Okay, so they not only for the hardware, they should spend millions of dollars on licenses for a particular year like that. So our system should be cost effective, and also our system should able to support unlimited concurrency. So whether that can be a workload concurrency or user concurrency, it should support that. And finally, okay, we need to have a system that is near zero management system. We don't, there should not be n number of knobs where you can able to optimize it. Everything that has to be done by a via that platform itself. Okay, the optimization, everything that has to be done by them. Our organization's main role should be managing the data, how they wanted to manage the data in that particular platform, and how they wanted to serve the data, how they wanted to govern the data across their organization. That should be our primal focus. It should not be like provisioning the additional resources to the teams, or like scaling up from time to time. Okay, or tuning the infrastructure. Okay, like securing the data, like encryptions, compressions, and everything. That should not be the primary focus for the organizations. How they wanted to store and manage the data, and how they can able to access the data and do the derive some value from it. That should be the major focus. So if any platform should have this kind of features, right? So organization tends to move towards it. So that is happened over this. Okay, so here, as you can see, these appliance based systems, when compared to the rdbms, so this provides the hardware optimization by this itself. Okay, and also the data is processed, okay, in parallel processing way. So these are the mpp based systems, right? So the first and okay, so the first is supported, this one is supported here. Okay, and some part of this one is also because the hardware automatically tunes for that kind of. Okay, and then here, when you came here, okay, from appliance to hadoop, what we have seen. Okay, so here it should support all data formats, and you should be able to query the data, okay, with native sql. That's what. Okay, so in a hadoop, earlier it used to be only java, then SQL support has been came with the respective of Hive. Okay, so like that, some enhancements has been happened, but that's what we looked here. Okay, and then when you came from Hadoop to here, so we want the unlimited scalability. Okay, on-demand scalability. Okay, on-demand scalability, and this one. Okay, the cloud is more cost effective than the on-premise systems, right? And with on-demand scalability, we used to able to get the concurrency that is needed also. Okay, and the systems like snowflake, okay, the systems like snowflake tries to add all of these, okay, all of these characters to that particular warehouse system. Okay, you got it. So, what makes Snowflake stand out, right? Snowflake stand out for its simplicity. So, everything, okay, Snowflake, there is a infrastructure management service in the backend that would run, that is going to be optimizing every operation of the Snowflake. We don't have to do anything. So, that's why when you are upskilling in Snowflake, so it doesn't matter you are looking for a developer role or you are looking for a admin role, because every snowflake training, right, so should cover all of this, because there is little much to do in the admin area. Okay, so that's why we will also cover the admin activities, what kind of activities that would be there. Okay, if you are coming from admin background, so you are also very much get a transition towards the development side also. Okay, with snowflake. Okay, snowflake stands out for its simplicity, elasticity, scalability, and its very innovative architecture and its features. Okay, what are those? I am going to just list them down. Okay, so that makes snowflake one of the fastest growing data platforms and a leader in that market. Okay, in the data market. Okay, any questions? So this is the Snowflake architecture, and Snowflake can be hosted on these cloud platforms. There are three public cloud platforms as of now in the market, that is AWS, Azure, and GCP. And Snowflake can be hosted on any one of these platforms. Okay, so that makes Snowflake as a cloud agnostic tool. and this is the Snowflake architecture. So I will try to make you understand what this three layers would mean. Okay. Yeah. So if you have any questions before we move forward, please let me know. Yeah. Also, like we started late, right? So it would take like another 15 to 20 minutes. Okay. So yeah. And one more thing, I think I forgot about this one. So if you want further communication from our team, right? Try to register. I am going to share this particular link here. Okay. So if you wanted to get further communications from our team, try to fill this form. Our team is going to be getting back to you on this. Okay. Yeah. So you can do this. You can open a link and you can do this after the session also. Okay. Yeah. Okay. Yeah. Okay. So let's list out the Snowflake capabilities. As you know, Snowflake is started as a cloud data warehouse. So as of now, I'm going to be focusing on data warehousing only, and later we'll see how data lake, enhancement, to the Snowflake data warehouse, how it has incorporated data lake features, how now it has become into a evolved into a data lake house also. Okay, so we'll cover all of those, but as per the demo purpose, I'm going to be introducing you to Snowflake as a data warehouse platform. Okay. Yeah. Okay. Yeah. So if you have any questions, please let me know, guys. So I want the sessions to be as interactive as possible. Okay. Yeah. Okay. So the first feature of Snowflake is it separates. This is the first platform that separated the compute from storage. So earlier, all the database systems are tightly coupled. Data warehouse systems are tightly coupled. That means if you wanted to store more amount of data, you should also there is a like a shared disk architecture, shared nothing architecture. You may have heard about them. All of them are tightly coupled. Okay, storage is tightly coupled with compute. If you wanted to increase any one of this particular resource, you need to increase the another resource also. Like if you wanted to increase more storage, okay, proportionally you should also increase the compute also. Okay. But Snowflake introduced this separation of for the uh, relational SQL data warehouse systems. For the SQL data warehouse system, Snowflake introduced this separation of compute from the storage. That makes Snowflake, right, you can able to hold even petabytes and exabytes of the data also. Okay, so we know terabytes. Okay, uh, 1024 terabytes is 1 petabyte, and 1024 petabytes is exabyte. Okay, just imagine the scalability of in terms of storage you get. And also Snowflake uh, gives us, okay, a feature called independent warehouses. Okay, independent warehouses for processing this data. So this would become a a single source of truth for us. That means all of the organization's data would be maintained in one place. Okay, with independent warehouses or clusters. Okay, compute clusters. Okay. Okay, so you can able to create any number of independent clusters as you want. Okay, and all of these, each and individual cluster would have access to the entire data. Okay, given that you have access, like there is a some access control framework, right? So suppose you have entire access to the data. That means even single warehouse can able to access the your entire organization's data. So because it separated the storage from the compute. Okay, individually these can be scaled, these can be provisioned, this can be uh, utilized based upon the requirement, based upon the team's requirement. So you can able to provision the only required data to that particular team. Okay, and also in order to perform cross functional, okay, cross business units or cross functional analysis also, still you can able to do, just need to have access to the data that you can able to get by running a grant command, as simple as that. So there is a access control framework which you would understand later, but Snowflake has this capability of elastic scaling, so you can able to scale on within few seconds to the smallest uh, cluster to very large cluster that is possible in Snowflake. Okay, so just wanted to show you what is the size of the Snowflake cluster, right? Okay, so in Snowflake, this compute clusters or warehouses are going to be sized based upon the t-shirt sizes. We have extra small, small, medium, large, like that, right? So similarly, extra small to 6XL. So this extra small would have one compute server, okay, of 16 gigabits of RAM, like a 8 core CPU, okay, 8 core CPU, and 200 gigabits of okay, like a SSD disk. So this is the capability. Okay, small is two times the extra small, so you just multiply these two times. Medium is two times the small, that means four times the extra. Okay, large is eight times, so like that, like that. So this is the 512 times of this one. Okay, so this is for one cluster. Snowflake supports a multi-cluster a warehouse also, multi-cluster warehouse. That means for one cluster you have this capability. Like this, you can have up to 10 clusters, 1 to 10 clusters you can have. Okay, you can have 1 to 10 clusters. Okay, so this is the true scaling that organizations has been looking for. Okay, so just imagine the kind of scalability that you do have here. Okay, so you would understand this, all this, what is a warehouse, what is a single source of truth, you may not know at this point, but I will try to make you understand everything in coming sessions. Okay, so that's the compute. Earlier, if you want this kind of thing, so there is a long process of even if you acquire the like a hardware resources, okay, in order to incorporate them to the your existing server, the data has to be redistributed. It becomes very hectic. Okay, it becomes very difficult to scale in traditional systems, but with Snowflake, so you can come from extra small to largest possible warehouse within few seconds. So to the largest possible, it would take like a few seconds, but if it is like till 2xl, within milliseconds it can able to scale. Okay, because for 6xl it has to like allocate you this many resources, right? So it would take some time to provision those additional resources that we requested. Okay, that's why here within few seconds, like 10 to 20 seconds it would take here, but whereas from extra small to 2xl, milliseconds it can able to accommodate our request. Okay, so basically here you have a multi-cluster capability for our warehouses. This gives us the desired concurrency for us. Okay, I talked about workload concurrency and user concurrency, right? So this gives us the user concurrency for us. And workload concurrency, you can able to create any number of warehouses, hundreds, thousands of warehouses. The one thing, the size that I showed, right, that is for one warehouse only. Like that warehouses, you can able to create hundreds and thousands of warehouses as per your requirement. Okay, that gives you, and you can able to allocate each warehouse to a specific workload. That gives you the workload concurrency. Okay, all these are technical terms. If you don't know, don't worry, I will make you understand. Okay, in coming sessions. Okay, and with cloud systems there is only one thing. So pay for only what we use. Okay, pay for only what we use. So you don't need to use everything all the time, right? So whatever the resources that you are consuming, okay, only for those resources we are going to pay. That makes this a cost effective solution. And as you know, Snowflake can be hosted on all platforms. So Snowflake is a cloud agnostic okay, cloud agnostic data warehouse, okay, and that can run on AWS, Microsoft Azure, and GCP, Google Cloud Platform. Okay, and this all of this is completely managed by, fully managed by Snowflake. Okay, so the everything provisioning and everything, you just need to change, write a query, um, okay, to read the data, to do any kind of transaction. Snowflake is going to be provisioning required resources. Snowflake is going to be optimizing that query. Lot of query optimization is done automatically. Okay, so all of those will cover. Okay, so there is no fully managed by Snowflake. There is no hardware tuning. Okay, uh, hardware tuning or maintenance of our server. So everything is going to be managed by Snowflake. Okay, and Snowflake supports okay, Snowflake support semi-structured data, where you can able to directly query the semi-structured data, directly query semi-structured data using SQL. Okay, so Snowflake gives some extended SQL capabilities that allows us to query the JSON, XML, and everything. Usually, earlier in traditional systems, it's not possible, right? Yeah, and for unstructured data also, okay, unstructured data, Snowflake offers to store and okay, uh, provides some external function capabilities that can process the unstructured data and derive some attributes like collecting the metadata and from there and store it into our Snowflake. Okay, so in Python all of this you can able to run within the Snowflake. Okay, Python, Java, Scala, all these are supported. Okay, we'll come to that. Okay, don't worry about whether it is needed for you to learn Java, Scala, all of this. Okay, so you do Python is, as a data engineer, as a now data developer, right? Python is become essential. So having some basics around Python is going to be take you a long way. Okay, so apart from that, SQL and Python basics, you don't need anything else. Everything will cover. Okay, and Snowflake provides ACID compliance for the transactions. So for data integrity, okay, for data integrity, okay. So there may be some typos. Okay, yeah. Then okay, so Snowflake has some features like time travel. Okay, a cloning. So what is time travel? Usually in general sense, we can able to go back in time or go forward in time, right? So but with databases, going forward is not possible. We cannot able to see what data that is going to be coming next, because data warehouses contains the data that is extracted from the source systems. Okay, so going forward is not possible, but with Snowflake you can able to access a particular version of the data that is available in the past. Okay, for example, I wanted to do okay, like a point in time kind of analysis. So whatever the data that I have now, okay, and whatever the data that I have a week earlier, I wanted to do the analysis, do the comparison analysis between these two. Okay, I can able to, I don't need to maintain two tables for that. Okay, by using this time travel within a single query, okay, I can able to and using a same table, I can able to query these two different versions. Okay, so the time travel allows us to access any past version of the data. Okay, and cloning, right? So usually when we wanted to keep a backup of a specific table, what we would do, so we'd copy the entire data. Okay, so whereas Snowflake allows us to do the shallow clone. Okay, do the shallow copy. So what does this shallow copy would do is, so when I clone, I'm making some changes to the existing table. Okay, I wanted to keep the current version of the data as a backup. Okay, so anyway you can able to access it via time travel, but you wanted to persist the data for longer duration. Keep this backup for, let's say, 15 days or 1 month, like that. Okay, so at that time what I can do is I can create a backup by using a cloning feature. So what it would do is it would create another table. Okay, it would create another table as a backup table. Okay, so this backup table does not copy any data from the source table. Okay, it just copies the metadata associated to that particular version, and this particular backup table would have entire access to the data. So how it is possible is because of Snowflake innovative architecture. Okay, so we'll talk about architecture. So here you are seeing, right, this architecture discussion will talk about all of these features in detail, how it is. Okay, so Snowflake were able to introduce this kind of features. Okay, not only this, there is a data sharing. Okay, without physically moving the data, you can able to share the data to the other accounts. Okay, you can able to share the account data to the other Snowflake deployments. Okay, so all these are possible because of Snowflake innovative architecture. Okay, and even some third party data sets also you can able to import via a platform called marketplace. Okay, it's like a, okay, data sharing only, but here this is publicly available. Data sharing we do it privately only. The provider and consumer would get some agreement, and we are going to share the data, but marketplace it's publicly available. Okay, yeah, and Snowflake can be, like I said, hosted on multiple clouds, right? So here you can with Snowflake, it doesn't matter on which cloud that you have the data, on which region that you have the data. It doesn't matter for Snowflake. It unifies the data across cloud platforms and regions. Okay, so let's say you have one particular server in APAC region, you have another in US East region, another one in US West region, or you have a buckets, S3 buckets in these regions, right? Okay, all of them you can able to access from Snowflake deployment, one Snowflake account. Okay, so you can able to unify the data across cloud platforms, whether it can be uh, present in AWS or Azure or GCP, doesn't matter. You can still able to access all of the data from one single Snowflake account. Okay, and can able to load the data if you want. Can able to analyze, like federate the data by using external tables, iceberg tables, like a lot of functionality is there in Snowflake. You can able to do that. Not only this, okay, in this cross cloud multi-region only, not only you can able to access the data. So there is a database replication feature, right? So why we replicate the data? So in order to have, okay, same replica of the data, so in case the current database goes down due to some external factors, okay, we don't lose our data, we don't, it does not impact our business. So in order to continue our business, we need to have disaster recovery setup, right? So database replication and disaster recovery, okay, is managed via cross cloud and cross region. Okay, DB failover and failback, right? So all those features are supported by Snowflake, so you can able to achieve that. We'll cover that how to set up and yeah. And Snowflake has okay very mature data governance. Okay, Snowflake follows a RBAC, okay, role based access control. So to whichever the data entities that you wanted to give access to a specific team, you can only share that data to them. Okay, even though Snowflake would be your single source of truth for your organization, but that particular team need not to have entire access, right? Okay, so you can able to control the access via this RBAC. Okay, and it also provides okay some governance features like data masking, row level column level security. Okay, data masking is a column level security feature, then row level security. Okay, and some additional governance features like object tagging, tag based governance. All of those things you can able to do. Along with that, Snowflake has introduced so data interoperability. Okay, there is a new term that okay, interoperability. Yeah. Okay, so this is a new term that you may see in recent days. So that means here whatever the data that I have in Snowflake, I wanted to make it available for the other platforms. Okay, so like to the AWS Athena or to Databricks or to Presto, Trino. Like there are a lot of systems in data landscape. There is hundreds of systems, right? So your organization may be using some of those tools. Okay, so instead of making individual copies in each of those platforms, so you can keep a single source of truth, and from that you can able to federate the data that is needed. So that is done via open format okay, open format tables. Okay, open format tables. So here delta is one such kind of thing, iceberg is another one. Okay, Snowflake supports both of these. Okay, Snowflake supports both of these open format tables. Okay, so this because of this, so here it not only from Snowflake. Let's say you maintain some data in for example in S3, that data is being managed by some Databricks platform or like that. Okay, other team is using Databricks and they are managing their data here, and you can able to access the data, federate the data into the Snowflake, and so that Snowflake users can also able to do the analysis on that. Okay, so like this data interoperability, and very importantly, right, very importantly, Snowflake ecosystem. Okay, Snowflake ecosystem. So not only the traditional connectivity features that usually you should expect from a data warehouse platform, along with that, Snowflake provides along with that a Snowpark framework for higher level language transformations, like Spark kind of environment. If you want, you can able to do that within the Snowflake. You can build okay okay, you can build native applications or scalable applications via Streamlit and Snowflake native app framework. Okay, so for data engineer, this is not our requirement, but this is a thing that businesses are looking. Okay, how they wanted to serve their data. Whatever the data we data engineers maintain, right? That data should be serving to the users. Okay, so these are the uh, like ecosystem. Okay, like native machine learning and AI development within the Snowflake. Okay, all of this you can able to do from Snowflake. Not only the traditional ones. Okay, not only the traditional connections that you should expect from a data warehouse, along with that, along with that, okay, all these are being supported within the Snowflake. So that makes the Snowflake a big contender even for next 10 years to come. Every how the today current trend is moving, Snowflake is trying to include that particular feature. So many of the of you have a question that whether the Snowflake, if I learn Snowflake, what is the feasibility of this tool being valid in next 2 years or 5 years? Okay, so Snowflake and Databricks are here, okay, are going to be here, okay, because their like a new feature development, right, it's at a very fast phase, okay. So even if a market is moving towards AI and everything, Snowflake and Databricks have their capabilities, okay. So in order to achieve that, okay, that's why organizations they don't want to move their data from one platform to another platform if that particular feature is available. So that's why you would see a consistent, okay, opportunities opening up in the Snowflake, okay, in these areas. And whatever the current projects, they are not going anywhere, okay. Yeah. In short, there are a lot more features that Snowflake is having, okay, in terms of data engineering aspect, okay. So yeah, so this is the capabilities of a Snowflake, okay. So here you can able to Snowflake is a shareable, semi-structure ready, a hyper elastic and scalable, okay, really fast, cloning, time travel, a call with cost effective storage that can support multi-cloud with multi-cloud database, okay, with automatic database replication for the business continuity, okay. And with Snowflake, the traditional functionality, right, so you can able to build the your reports, build your analytics with the tools that your organization is currently having. And also you can able to uh, do like do more from the additional languages, not only SQL, like Python, Java would give open new doors for the newer generation analytics like machine learning and artificial intelligence. And these are it provides active integrations with the data science domain related services. And you can host your Snowflake on any cloud that you want, and you can able to work uh, um, with the data that any format or any type of the data that you need, okay. So that's what the Snowflake brings to the table. And all of this with a near zero maintenance platform that is delivered for us as a platform, as a service, okay, as a service, okay. Yeah. So and we only, not all of these services would charge us, we only pay mostly for amount of data that we are storing, and amount of compute resources that we use while querying the data, while doing some data processing. Only for those we have to pay, okay. With Snowflake, as you can see here, okay, it supports not only data warehouse, you can able to build a data lake within the Snowflake, and combinedly this would become a data lake house platform, okay. And this Unistore is, you can now become like make Snowflake even as a transactional system like a OLTP. Okay, Unistore is a OLTP workload that you can host within the Snowflake account, where you can able to this this is powered by a specific type of a table called hybrid tables. These hybrid tables are optimized for single row operations. Okay, that is expected from a OLTP system, right? So like that, even OLTP workload is also supported. And you have a data engineering capability, machine learning capability, and even app development via using Streamlit native app framework, that you can able to do it from Python, Java, and other languages, okay. And you can able to collaborate with other Snowflake customers, okay, via data sharing and marketplace like this, okay. So finally, okay, finally, This is what Snowflake is. Snowflake is a data cloud platform. Like now, earlier it used to be data warehouse. Its names as a Snowflake Cloud Data Warehouse, but now it has evolved into a cloud data platform. Okay, data cloud platform. Okay, so that is provided as a service that enables the organization to eliminate any data silos that you are having. So to make a single source of truth. Okay, to manage a single source of truth here by seamlessly unifying your data warehouses, data marts, lake, and any other kind of data silo that you are having. You can able to manage all of your data into a single platform. Okay, and you can able to serve to any kind of analytics. Okay, any kind of analytics. So as a data engineer, our major part is going to be this one. Okay, not the analytics part. So we need to extract the data from different systems, do the transformations. Okay, either ETL way or ELT way, but ELT way is going to be using the Snowflake within, is happening within the Snowflake, right? Nowadays ELT is the trend. Okay, so extracting the data from all of this, unloading the data uh, based upon the requirement. Okay, so you can able to manage the data in your data lake or the enterprise data warehouse, and from here you can able to build your logical data marts on top of this EDW. Okay, enterprise data warehouse, and this logical data marts are going to be given access to the business teams. Okay, that's what. So I don't have time to go much into this. Let's quickly show you what we are going to be planning here. Okay, yeah, I'm just reminding one more time, so please try to fill this form, guys. Yeah, so I think our you one like a drive. Okay, so to one of our previous batches. So I recently wrapped one batch. Okay, so there is a one Snowflake final. Yeah, so you would see all of those sections, right? All of those sections. Okay, so Snowflake introduction to Snowflake, DB objects, and you would see what are the different. Okay, like this, you would get recorded sessions for viewing. Okay, so you would see data loading and unloading. Okay, different types of data loading, native data pipelines like streams, tasks, and everything. Okay, so like all these are going to be covered. So it would be around 60 hours of the content that we try to deliver. Okay, and this is the architecture I would make you understand in real time. Okay, how the data is going to be managed in, right? So I would try to make you understand. Okay, so uh, we may not use the data sources, same data sources, but I will try to mimic these data sources and ingest the data into the Snowflake. Okay, and once you get the data to here, what are the different options that you do have to get uh, transform the data, normalize the data, and everything. Okay, and finally, uh, okay, so this thing, how do you manage the data within the Snowflake, is what we are going to be focusing on. Okay, so with this, let me stop here, and I wanted to take some questions from your side. Yeah, there is a one question from Sumit here. Will we be taught in AWS? Not only AWS, Azure and GCP is also considered, but mostly we would talk about AWS and Azure. GCP, there is very less number of clients that Snowflake is having. So I will show you how it would work with respect to the GCP also, but not in great detail, which I am going to be covering here. No, SQL is a prerequisite that you need to have for this Snowflake. Even basic SQL is going to be sufficient. Okay, um, so and as a like data engineer or a data analyst, these are the roles that you would be eligible for if you learn Snowflake, right? So SQL is the basic thing that you need to have. In every interviews, they are going to evaluate your SQL skill also. Along with the Snowflake, they would try to ask you a couple, 2 to 3 questions on SQL also. Okay, so that's why SQL is very important. You should have some basic knowledge of SQL. At the same time, along, if you are a beginner in the SQL, okay, so if you have basics, you can attend the session. But along with Snowflake, you should also improve your skill on SQL. Okay, that's what I would suggest. Okay, so it would not be taught in this because SQL itself is another 20 hours content. Okay, if I wanted to cover it thoroughly, and many people that are trying to learn Snowflake, right? They already are working professionals. They know their SQL. I think our training institute would have some kind of SQL, okay, training also. So I think you can check with them whether it would be given to you as a complimentary or whether it is. So if there is no such thing, you can connect with me. I can assist you in how to uh, like a parallel skill on SQL also, but you should have some basic SQL. Okay, so we regarding that, check with our team. Okay, so they can help you answer few questions, and if you still need some guidance on that, let me know in next sessions. I will definitely, yeah. Yeah, hi Sumit. Timing is going to be, um, it's not confirmed yet, and I too don't know. Our team is going to be sharing that information, so please try to fill that above form if you need to get some additional information. Okay. So, from this demo, you should understand one thing. Okay, so you need to understand the way that I'm teaching, whether the um, topics are planned in a structural way. Okay, so that you need to understand, and keep a trust. I'm going to cover everything in detail the same way that I covered here. Okay, demo here, I don't have time to show you anything hands on. Okay, and you too don't expect in demos to show you hands on, but apart from that introduction, right, everything is going to be hands on session. Like we would use the Snowflake account in order to make you understand how it would work. Yeah, Python, at this stage it's not mandatory, but if you want to get a better job with better pay scale, right? So organizations are looking for some basics around Python. Even for data engineer, um, if you take any other thing, so the orchestration is done via Airflow nowadays. Okay, Airflow is done via Python. Okay, it's the programming language for the Airflow, to build Airflow DAX is Python. Okay, so you should have some Python basics. I would help you on how to follow which resources that you need to follow in order to upskill. It's a very easier language. Okay, SQL and Python are the easiest languages in my opinion when compared to Java, C++, and other things, right? Yeah. So yeah. So like I said, I'm a like a Snowflake advanced data engineer, like a two times certified professional. So I've been working with Snowflake for around 5 years. By next month, it would complete 5 years. Okay, so anything that is related to data engineering. I also Databricks data engineer professional certified, in Azure data engineer certified. Okay, like on all these platforms, I have some like a decent exposure on AWS, Azure, and all of this. So I can. If you if you are a working professional, if you need any kind of guidance, can always reach out in our sessions, so that other people can able to understand how in real time the scenarios or situations would come up, and how dynamically we need to think our thought process. Okay, yeah. Like that. Okay, hope you are getting my point, what I'm trying to say. Yeah. Yeah, any other questions? You can use unmute, and you can use your voice also to ask any questions. We are going to grow from basics to the advanced level. Okay, so this training course would okay, so if you go to the Snowflake website, there is a ILT. So each course would be around $3,000 something. Okay, so in this course we'll try to cover the Snowflake fundamentals, Snowflake data engineer. There are two levels in the data engineering one and data engineering two, and the administrator. Okay, so we'll try to cover the concepts in all these three courses. Okay, so that much extensive our curriculum is. Okay, uh, even if it takes few more days also, we would not leave anything out. Okay, um, yeah, no. So the main purpose of this training is in order to share our knowledge only, right? In order to share the, so there is no need for hurrying up and everything. Okay, so yeah, like I said, it is going to be around 60 hours of live sessions, and if we need more understanding on AWS, I would share some previous recordings, like more understanding on the AWS S3, like that. Okay, so some additional videos are going to be shared for your better understanding. So combinedly you would get like around 70 5 hours of the content. So you don't need to look for anything else with respect to the Snowflake. If you properly prepare whatever we are discussing in our sessions, right, you can able to crack any interview with 2 to 3 years of experience, that you can showcase yourself as a Snowflake professional. Okay, with the 2 to 3 years of experience, working experience. Yeah. Yeah, I my throat has gone. Yeah.
Hi Shekhar, Srinath here.
Hi, Shreya. Yeah.
Actually, I wanted to know this. I'm a working professional actually.
Yeah.
I have experience in different domain. I'm not in related to data.
Not a
And,
issue. Not a
uh,
issue, but you should have some SQL knowledge. Whether in your previous role, whether you have interacted with any databases.
I'm not related to databases job
Okay.
actually. I'm a
Okay.
transaction operations site actually.
Okay. But
That is the
as
reason.
like I
Mhm.
said, right, you should have a SQL. SQL understanding. If you have that,
Yes.
then we can able to learn the functional, architectural side of it, also
Mhm.
technical side of it. So
So first, I
every
need to.
yeah, every session, every new concept that we'd go, I would have a some 30 to 45 minutes on the architecture itself. Okay, so that would give you some basics around it, but you should have
Okay.
SQL. Yeah.
Okay. In this Snowflake sessions itself, the SQL basics would be included.
Yeah, we are going to write a SQL queries only in order to
Okay.
do anything, like
Hmm.
loading the data, creating the objects, or everything, setting up some kind of integrations and everything. We write SQL queries only. Okay,
Okay.
some basic SQL is going to be sufficient. Okay,
Okay.
like a DDL, DML, select statement.
A DDL,
Uh,
DML, and something
those are
joints.
sufficient for you to understand how what we are doing. On that,
Yes.
parallelly you can upskill. Okay, as I told, in interviews they are going to be focusing
Hmm.
on uh, SQL also, right? So they would give you some like a sample tables and ask you to write a query for it. So
Hmm.
like I said, it is going to take 2 to 2.5 month time, right? So
Hmm.
you can parallelly upskill on
Parallelly by the
SQL.
time.
Yeah, by
Okay.
that completion of our course, by the
Hmm.
time you wanted to appear for the interviews, so you should
Hmm.
be at a intermediate level proficiency in SQL also. That's my
Got it.
point. Yeah, yeah,
Thank you very much for input.
yeah. No problem. Thank you. Thank you for the question. It's a very common question.
Yeah, it's
Like
very common, but I wanted to know.
yeah, yeah, so that others also has. Thanks for that question. Okay, is
No problem.
advanced SQL required for the Snowflake? For data engineer, advanced SQL is not necessary, but for
Hmm.
data analyst, right, so you should have some because you need to analyze the data, right? So at that time you may have to write your analytical queries, but it need not to be advanced SQL. So but over a period of next 2 to 3 months you should acquire that proficiency in SQL also. The same I'm going to guiding you on the Snowflake side. In the same way, you should, if there is a any training offered from Provoke on SQL, you should check with them. Otherwise, you can connect with me. I will guide you in that SQL aspect also. So what are the concepts that you need to be focusing more on? Yeah, like that. Okay. So
Got
for starting the training, you should have some basic SQL about this DDL, DML, select statement. Okay, some basics around it, not very deep. Okay, but some exposure on the SQL is going to be sufficient. Yeah. Okay. Yeah. Any other questions?
Yes, sir. Sir, good morning, sir. I'm Naveen speaking.
Yeah. Hi, Naveen. Good morning. Yeah. Please go on.
Sir, actually, I'm working on testing, automation testing.
Okay.
I have 10 plus years of experience, sir, in this automation testing.
Okay.
So now I want to learn this Snowflake, sir, and I want to change my technology into Snowflake in future.
Oh, yeah.
Uh,
Okay.
so,
So,
what the
yeah. Yeah. Please
experience
go
can
on.
I get in this one, sir?
Yeah.
Uh, so
Definitely.
after completion of this,
Upon completion of this course you would be very confident to make a transition to the data domain. Okay. And also the clouds. Snowflake is, you can treat Snowflake as a stepping stone into your cloud data engineering side, because Snowflake is a SQL based one, and SQL is the very basic uh, language, right? Okay. So uh, and along with Python, basic Python. Okay, so you can move into the data engineering side, and data engineering is one of the latest trending roles. Okay, and every organization is looking and willing to pay a premium price for this kind of professionals. Okay, so if you wanted to make a career transition towards the data domain, okay, so instead of going for data science or data analyst, so with data science it's more complexity. You need to know about machine learning and some coding and everything. Okay. uh, with the data analysts there are too many data analysts. Okay, so there are less number of opportunities that you would have. But for data engineering, there is a, if you go and check for the data engineering positions, right, so you would see a huge demand on that, and every organization is having a requirement on these data engineering roles. Okay, data engineering domain is the one of the fastest growing nowadays. Okay, and you can make a transition from any non-data domain to data domain via Snowflake, because you only need SQL for it. Once you make that, right, make the transition, you open the door for other uh, cloud platforms also, because Snowflake can be hosted on all three major cloud platforms. So while working on Snowflake, you you are going to be working on some of the cloud features, which I'm going to show you here. In even real time also you are going to be interacting with those services. With that knowledge you can easily make a transition to, you can learn and you can upskill on those, you can able to make a transition as a cloud data architect, like that. Okay, so there is a lot of scope for this. Yeah, I hope you got that, Naveen.
yes, sir.
So
Sir, can I keep 3 years or 5 years, sir?
yeah, yeah, you can, like on Snowflake with this training, if you prepared well enough to whatever the topics that we covered, right, so definitely you can keep 3 years. 5 years, it's going to be very difficult for you to manage, but 3 years you can keep. Yeah.
So can I put like 7 years into automation testing and rest of recent experience
No,
into
like
plus,
you can keep five
3
years like in testing side, couple of years in database side, because you already know SQL, right? If
yes,
you
yes.
are going to be applying on Snowflake, okay, so you can apply it on keep it on like a database developer. either Oracle or SQL Server for 2 years, and then Snowflake on 3 years. So you would have a on data domain more than 5 years, right? So
Yes.
um, your profile looks more like
Okay. Sir,
competitive, right?
PL SQL also necessary for this one or only SQL?
So here, PL SQL is not that much necessary. If you wanted to do some kind of transaction, like a data processing, so you can able to create that functionality. But even in PL SQL, like in Oracle or like that, you don't need that much depth. But you should know how to write a select statement. Okay, so if you know that select statement, like dynamics of the select statement. Okay, so with the window functions, with the group bys, with aggregations and everything, so that is and having basics around like what is a stored procedure, what is a function, like definitions of it, that is sufficient. So here in Snowflake there is no cursors, there is no triggers or everything, only functions and procedures basics are sufficient. Okay. Yeah.
Okay, okay,
So
sir.
we'll cover some basics around it. Okay. Yeah, in Snowflake, how to create functions, how to create procedures in multiple languages. We'll cover some basics around it. Okay. Yeah. So
This foreign key, primary key, as usual, we can implement
no,
in.
you don't need to worry about those in Snowflake. Okay.
Okay, okay, sir. Thank you.
Primary and foreign keys are not supported in Snowflake. Indexes
Okay.
are not supported in Snowflake. Because its architecture is different. You would get to understand them once we go to the performance chapter. Why it is not supported, why it is not necessary, all of those things. Yeah. Okay. Yeah.
Thank you, sir.
Yeah. Sure. No problem. Yeah. And any
Hi,
other
sir.
questions?
Satish here.
Yeah. Hi,
Hi, sir.
Satish.
Satish here. Yeah.
Yeah.
Yeah. Nowadays, everything is all are telling like cloud. So
Hmm.
I am a PLSQL developer around 5 plus years
Okay.
of experience.
Okay. Yeah. Your voice
I
is breaking out,
don't have
Satish.
yeah yeah I don't have any technologies like Python, Java, .NET. I don't know anything except SQL and PLSQL.
Yeah.
It is okay
The major
to
skill you already have, Satish. Okay.
yeah.
Only you just need to gain some basics around Python. You should be open to it, because if you are going to be coming to the cloud side, so uh, every service uses and leverages Python. Okay, so Python basics should be mandatory. So that's why I'm saying SQL, intermediate proficiency of SQL and basics of Python is mandatory. Okay, so by the time you go to the interview. Okay, so with respect to the cloud, whatever the cloud services that we need with respect to the Snowflake development, Snowflake data engineering, we cover um, everything. Okay, so I would make you understand in which capacity that we would use, what are their characteristics, and what is the purpose of that particular service, and like that, we'll cover everything. Okay, so upon that, if you wanted to get familiar with other services, I will provide some guidance on which services that you need to look into. So you can go over the YouTube and get some overview on how that particular service, what kind of service, capabilities it is offering, and what are the characteristics of that particular service. You can look into that more. Okay, at that time. Yeah,
Thank you, sir.
sure, no problem. So, any other questions? So it's sorry to take such a long time. Okay, I want yeah, no. I wanted to answer everything. If you have any questions, okay. System admin say if I need to change Snowflake, yeah, definitely. This course is going to be um, more than enough for you to become a Snowflake. Make a transition to Snowflake, whether it is for a data engineering or admin side. I'm going to show you the list of admin activities that is needed. Okay, that has to be done from Snowflake side. If you already have some database admin experience, then this course is going to be more than sufficient. Yeah. and I will show you, because this is a trial account, right? So few advanced features are not enabled for us trial account, but I would guide you in that aspect of where to go and read more about it, and where you can able to get a better understanding of those. I would guide you during that particular time. Yeah, definitely. Sure. So yeah, thank you guys. Thanks for giving such a time during your weekend. And if you don't have any questions, we'll close the session here. And I hope all of you have filled that particular form. And let us know if you have any other questions. Okay. So looking forward to in the next session. Okay. So I think a few sessions are going to be free only, like a demo only, I think. I don't know, but yeah. So try to join, try to get some exposure on Snowflake. Okay. Uh, yeah.
So thank you, Shekhar sir. Thank you so much. Thanks for your time. And thanks for joining everybody. So please approach the Provoke Trainings. Any details we will update you. Thank you so much. Thanks for your time. Have a nice day. Have a
Yeah.
nice weekend. Thank you,
Thank
Shekhar
you.
sir.
Nice
Thank you.
weekend. Yeah. Bye.
Thank you. Bye bye.